Today we are going to look at a new topic called trigonometry. Let us say we want to measure the height of a lighting pole. You could take a scale and readily measure the height. Or maybe you could climb on a ladder and drop a measuring tape to measure the height of this pole. Is there an easier way though? You could take another object such as an iron nail and look at the shadow of this iron nail. So when the shadow of the iron nail is equal to the height of the iron nail, you can measure the length of the shadow of this lighting pole and you would know the height of the lighting pole. But for that, you would have to wait for that exact time when the shadow equals the height of an object. But let us consider this, that shadows of all objects would be as short or as long as other objects, which basically means that the shadow of the iron nail is to the height of the iron nail would be equal to the shadow of the lighting pole is to the height of the lighting pole. Or we could say that small b is to small p would be equal to capital B is to capital P. We can actually look at right triangles formed by these objects and their shadows. Now since one of the angles is a right angle in both these triangles, and the horizontal angle would also be equal. Why? Because the position of the sun is the same for all objects. So they would form the same horizontal angle. Hence, these two triangles would be similar. In fact, all such triangles formed by objects and their shadows would be similar to each other. So once again, we arrive at the conclusion that small b upon small p would be equal to capital B upon capital P. Now let us look at one of these triangles. So we call the shorter sides as small b and small p. And we can draw as many similar triangles as we like. Now let us call the horizontal angle theta. Now small b stands for base, small p stands for perpendicular and small h stands for hypotenuse of this right triangle. The base is the side adjacent to angle theta. The perpendicular is the side opposite to angle theta. Now study of the ratios of the sides of such right triangles is known as trigonometry. So the ratio of perpendicular is to hypotenuse or p upon h is known as sine of the angle theta. The ratio of the base is to hypotenuse is known as cosine of the angle theta or cos theta. There is another ratio called tangent of theta, which is the perpendicular upon base. It is also equal to sine theta divided by cos theta. So it's a ratio of ratios. Now we can form as many combinations of ratios as we want, taking any two sides at a time and in any order. So the reciprocal of sine theta is known as cosecant theta. The reciprocal of cosine theta is known as secant of theta. And the reciprocal of tangent of theta is known as the cotangent of theta. In short, these ratios are called cosec theta, sec theta and cot theta. Alright, what if the vertical angle was called theta? Then the definition of my small p and small b would change. The trigonometric ratios would stay the same. Let us look at a few problems. In the given figure, find tan A minus cot A. Now we are given a right triangle. One of the shortest sides measures 12 centimeters and the hypotenuse measures 13 centimeters. Now we are looking at trigonometric ratios of the angle A. So let us call angle A as theta. Now the shortest side opposite to angle theta would be called small p. And the side AB would be called small b, which is equal to 12 centimeters. Similarly, small h would be 13 centimeters. Now, applying Pythagoras theorem, we can easily find the measure of small p. Small p comes out as 5 centimeters. Now let us recall our trigonometric ratios. We want to find tan theta and cot theta. Now tan theta is small p upon small b and cot theta is the reciprocal of tan theta. So it would be small b upon small p. Substituting the values, we get tan A as 5 upon 12 and cot A as 12 upon 5. Hence, tan A minus cot A would be equal to minus 119 divided by 60. Let us look at another problem. If 8 times cot theta is equal to 7, evaluate 1 plus sin theta times 1 minus sin theta divided by 1 plus cos theta times 1 minus cos theta. Now we can write cot theta as 7 upon 8 by rearranging the given identity. Now once again, let us recall our trigonometric ratios. We know that cot theta is equal to small b by small p. And we have to evaluate sin theta and cos theta. So we are going to use 3 of these trigonometric ratios here. Let us park these 3 formulae for reference. Now cot theta is equal to small b upon small p. Let us draw a right angle triangle and call one of the acute angles as theta. So the side opposite to theta would be called small p, which is equal to 8 times k units, and the base would be equal to 7 times k units. Please note that cot theta is a ratio, so we don't know the absolute values of the base and perpendicular, we only know their ratio. Hence, we are multiplying both of them with a common factor k. Now we can once again apply Pythagoras theorem to find the hypotenuse in terms of k. H comes as square root of 113 times k units. Now let us apply the formulae for sin theta and cos theta. Now let us substitute the values of sin theta and cos theta in the given expression. Recall the algebraic identity, which is a plus b times a minus b. It is equal to a square minus b square. We can use this identity for the numerator as well as the denominator. Simplifying, we get the expression equal to 49 by 64. There was another way. We could have applied the algebraic identity to the expression first and then substituted the values. Let us look at another problem. In triangle PQR, right angled at Q, PR plus QR is equal to 25 centimeters and PQ equals 5 centimeters. We have to determine the values of sin P, cos P and tan P. Alright, let us draw the right angled triangle and name the vertices as P, Q and R. Note that Q is the right angle. Now since we have to find the trigonometric ratios corresponding to the vertex P or the angle P, let us call angle P as theta. Now the side opposite theta, which is the side QR, becomes my perpendicular. The side PQ, which is adjacent to theta, becomes my base, and PR is my hypotenuse. Now we are given B equals 5 centimeters and we are also given H plus P equals 25. So applying the Pythagoras theorem, we can rearrange the Pythagoras theorem and write it as h square minus p square equals b square. Let us apply the algebraic identity as we did in the previous problem. So we can expand h square minus p square as h plus p times h minus p and substitute the value for h plus p. Dividing both sides by 25, we get h minus p equals 1. We also know that h plus p equals 25. Adding these two equations, we get h equals 13. So my h is 13 centimeters. So we can easily find out the measure of perpendicular, which is 12 centimeters. Let us recall the trigonometric ratios. Now here we have to find sine, cosine and tangent of angle P. So we are going to use sine theta, cos theta and tan theta. Once again, let us park our formulae and substitute the values. So we get sine theta or sine P as 12 by 13, cos theta or cos P as 5 by 13 and tan theta or tan P as 12 by 5.